Discontinuity of functions. In our previous video, we discussed that if the graph of a function can be drawn without any breaks or gaps, then we call the function as continuous. And if there is any break or gap in the graph of a function, then we call the function as discontinuous. This means that the graph of a discontinuous function will show a break at the point of discontinuity. For example, this graph shows discontinuities at x equals to -4 and x equals to 2. But how do we determine whether the given function is discontinuous at a point? Well, one way is to draw the graph of the function if that is quicker. And the other way is to check algebraically, and which is what we are going to discuss now. A function f of x is said to be discontinuous at a point x equals to a if limit of f of x at x equals to a does not exist or it is not equal to the value of the function at x equals to a. This could happen due to 4 reasons. First, f of a is not defined. Second, either left hand limit or right hand limit of the function at x equals to a does not exist. Third, both left hand limit and right hand limit of the function at x equals to a exists, but they do not agree to the same value. Fourth, both left hand limit and right hand limit of the function at x equals to a exists and also agrees to the same value, but the value is not same as the value of the function at x equals to a. A function can have discontinuity at a point x equals to a due to any one of these reasons. Let us understand this concept with the help of an example. Suppose we have this function and we want to discuss its continuity at x equals to 0. Then at x equals to 0, the value of the function is 2. Now let us find the left hand limit of the function at x equals to 0. It is given that when x is less than 0, f of x equals to x minus 5. So the left hand limit of the function at x equals to 0 will be minus 5. Now let's find the right hand limit of the function at x equals to 0. It is given that when x is greater than or equal to 0, f of x equals to x plus 2. So the right hand limit of the function at x equals to 0 will be 2. Since the left hand limit and the right hand limit of the function at x equals to 0 does not agree to the same value, so we can say that the given function is discontinuous at x equals to 0. So this is how we check discontinuity of a function at a given point.